Good afternoon, everybody. Welcome on a dark and somewhat rainy Monday afternoon. It's really spooky out there. I'm getting ready for Halloween. Monday afternoon of Chem 170 Organic Chemistry with your host, me, Dr. White. Don't forget, there's only six more shopping days till Halloween. My favorite are Kit Kats, but I already got them. But get your good stuff. Like I need that, like a hole in the head. I don't. But anyways, hi. All right. I don't know if I said last Wednesday, today or Wednesday, but I think it makes more sense. Let's do it Wednesday. On Wednesday, I will go through the carboxylic acids and ester problem set. This gives you a couple extra days to do the problems before I do. So if you have any questions, you can ask. Because remember, in my class, there's no such thing as a dumb question, ever. Also, let me remind you, tonight from 5, actually late afternoon, but tonight from 5 to 6:15, I'll have my office hour. I also have it Wednesday at the same time. And if you have any questions whatsoever, stop by. All right, let's get back to work where we left off. And we were talking about amines, amides, and heterocyclic compounds. And we had talked about amines are derivative of ammonia. Ammonia and when you replace the hydrogens with R groups, you have amines. I don't think I did this last week, but I sometimes do it, and this is a good time to do it. Now, this is the general structure for any amine. And remember, R prime and R double prime can be hydrogen. And I talked about last week, how do you name amines? Well, I'm only teaching you the common way, and that's you name each R group as the alkyl group or cycloalkyl group or aryl group it is, and then aryl means benzene, and then add the word amine. I don't think I mentioned this. Do I have a slide for it even? A couple of things I don't have slides for in this chapter. Bad, Dr. White. All right, let's talk about a couple things. First of all, there's a special remember there's 3 or 4 bonds. Having trouble with my B's today. I don't know why. Maybe I need a new tip on my stylus. I've got to change it. That's better. Unlike carbon, where there's always 4, for amines, there's always 3 bonds to nitrogen. We'll learn later on when you get 4. Now, this compound is not called benzenamine or benzylamine or benzenamine. It's called, and I always spell this wrong. I think that should be an I. So I'm going to look it up because I think that should be an I, but let me. I spelled it right. Look out. Dr. White's on a winning streak. Did I ever tell you I was first one down in the spelling bee? Probably still am. But for some reason, I always put an I there. I remember. All right, you should know. This is for this compound. This is both the IUPAC and the common name. IUPAC, like they've done before, took a long-standing common name and made it the IUPAC name. That's aniline. And we'll learn later in the semester, or this chapter actually, that this is used to make other molecules that are all the dyes for things like your clothes. And if you're not wearing something that's pure white color, it's made with, it's called an aniline dye, which is made from aniline. Aniline is also used to make certain types of what I'll teach you later on, urethane information. Ooh, that reminds me, speaking about stuff I should talk about, did any of you happen to pick up a bottle of vinegar and look at it and see, ooh, it's got acetic acid in there, a carboxylic acid? Did you happen to pick up a bottle of ketchup or mustard and see it has vinegar in it, which is water and acetic acid, and acetic acid is a carboxylic acid. Now, did you happen to pick up a bottle of nail polish remover? Oh, I didn't polish my nails. My grandfather used to, in the barbershop, have a clear coat put on there. That was the style a long time ago when I was real little. But anyways, do you happen to pick up a bottle of nail polish remover and see it has ethyl acetate? And that's an ester. Or one last thing I've got to ask, well, you can't smell it now, but if you could smell some flowers, or if you happen to eat a banana or other fruit, did you taste and smell it? And think about that an ester is responsible for the odor of flowers and of many fruits and vegetables? If you didn't, you should, because organic chemistry is all around us. I stole that from SpongeBob. And it won't hurt, I promise. Trust me. I'm a chemist. Does that work? How about trust me? I'm an organic chemist, to think about organic chemistry outside of my classroom. All right, let's get back to amines. Now, this is aniline, and we went through amines. Now, let's talk about an area that's really near and dear to my heart, because I have about 9 patents with this type of functional group. And that is I don't think I talked about this last week. If not, it's a good thing to talk about. Quaternary ammonium salts. I think I mentioned it briefly. This is an area I'm a world authority in. And for many years to help pay my mortgage, it still does. I don't have my mortgage anymore. I paid that off, but it got me new cars and got me around the world. And I'll try and be a good and not call them the slang we usually, if you're in the industry, you can just call them quats, but I won't. Now, a quaternary ammonium salt, I think I started talking about this last week, but has 4 groups on nitrogen. And because nitrogen for one of these groups provides both electrons, it has a positive charge, and all molecules in nature have to have a net zero charge, so you need an anion. And for this class, I'll use X halogens, which can be fluorine, but it's so rare, I'm not going to put it down. For my class, chlorine, bromine, or iodine. Now, these are quaternary ammonium salts. Now, how do you name them? Well, the common name, which is all I'm going to teach you, nobody uses the IUPAC, is named I've gotten in the habit of not using cursive because my other class, half the people can't read it. Not my handwriting, cursive in general. That's sad. And you can also see it the way they sign their names. I can't read it. All right. For a quaternary ammonium salt, name each R group as the alkyl group it is, and you put that in the front. Next, add the words ammonium halide at the end. Now for halide, what I mean is for chlorine, that's chloride. For bromine, that's bromide. And for iodine, that's iodide. And that's how you do quaternary ammonium salts. So let's look at one. And if you look at on the screen, what do you see that's different? Ooh, a nitrogen, it's got a positive charge, and you got a halogen anion. This is a quaternary ammonium salt. Notice this tells you you've got four groups on that nitrogen. And a halogen anion. So how do you name that? Well, since it's a common, it doesn't matter which one you put first. There's two methyl groups in organic chemistry or chemistry in general. Two use the prefix di, dimethyl, diethyl. And since it's a quaternary ammonium salt, we use at the end ammonium halide. It's bromine, so it's ammonium bromide. Now, let me have you share the fun. You can have some fun. And there's one for you to have fun. What would be the common name of that molecule? This thing, 6 months ago, would you even know what I was talking about? Would you know what an alkyl group is? Think about how much you've learned. Doesn't that feel good? I hope it does. All right, everybody done? Give me a thumbs up when you're done. Thank you. All right, I think everybody's done. Let's take a look at this. Now notice what's different? Nitrogen, it's got a positive charge, and that has also an anion, and therefore this is a quaternary ammonium salt. Now, in the chemical industry, you can have other anions, but I'm going to stick to halogens. And again, this is a quaternary. Quaternary ammonium salt. So we have two methyl groups, an ethyl and N-propyl. Well, doesn't matter which order you have. So we have dimethyl, ethyl, and propyl. And then I'm going to come down here because I'm running out of room. I don't want to get into here. Ammonium. And here we have iodine, and we call the iodine iodide. And that's how you do quaternary ammonium salts. But on test 3, like test 1 and 2, for nomenclature, there'll be 2 types of questions. Now, test number 3, I'm going to do something a little different. For draw the structure or give the name, I will have give the IUPAC or the common name. Since I'm not teaching you amines or quaternary ammonium salt, IUPAC names. Nobody uses them. But the other skill you should have, given a name, draw the structure. And if I were to give you 3 points each, and just so you remember, I haven't written it out in a long time. And I also might put condensed where you don't have to show the actual hydrogen carbon bonds. How would you do this? Well, you come this way and say, oh, chloride, ammonium, and that could be a quaternary ammonium salt. I see tetramethyl. Tetra means 4. Quick review. Quick review. Remember, a prefix di means 2. Tri means 3. Tetra means 4. So I have a quaternary ammonium salt. I have 4 methyls. Being a lazy organic chemist, I'll do that. And what's my anion? Chlorine is a chloride anion. Now, there's another way you could have written it, which I wouldn't, but I would give you full credit. And neither one would be correct. Again, ammonium chloride tells you, say, quaternary ammonium salt and later on it might be something else, but for now, quaternary ammonium salt and tetramethyl. Remember, tetra means 4, and you know CH3, your good buddy, methyl, that's how you do it. So I'm going to let you have some fun. What would be the structure of a molecule with a common name, trimethyl isopropyl ammonium chloride? Thank you, Megan. Thank you, Joe. All right, I think Emily might be done, so let's get moving forward. If we go from right to left, chloride, ammonium chloride, that might be a quaternary ammonium salt. And notice there's not only one, but 3 + 1, 4 groups. And this is a quaternary ammonium salt. If it looks like I got a big smile on my face, I do, because Dr. White loves quaternary ammonium salts. They've been good to me. I've been good to them. Oh no, it's awful spelling Monday. Sorry about that. Anyways, we've got a quaternary ammonium salt. It's got an isopropyl and 3 methyls. One way of drawing it. It doesn't matter which side you put the isopropyl group. I'll put it here. I could have easily put it down there. One thing, you don't have to put the charges down. I will. What's the anion? Chloride tells you it's the Cl minus, chloride anion. And there's another way you could have drawn this. 3 sides have methyls. Doesn't matter which 3 sides. Again, you do not have to put the charges down, but I will. And that would be trimethyl isopropyl ammonium chloride. Now, there's a very, very special quaternary ammonium salt I like to talk about. And R sub T is called the tallow group, or sometimes called the tallow alkyl group. I use this tallow group. And I'll teach you later on that that's our group that has either 16 or 18 carbons, and it can and cannot have a double bond. And Tallow, I'll teach you where it comes from. Now, this molecule, which you should know, is called ditallow. I've seen some people put tallow alkyl, dimethyl, ditallow dimethyl ammonium chloride. Now, why is this special? Well, I'm going to tell you. Remember a while ago, I've been saying every once in a while, why am I learning this stuff? Why would somebody want me to learn this? And the obvious answer is you want to get a good grade so you can get into a program or a school to get your degree in whatever major you want. And they told you you had to take 1 semester organic. Well, ditallow dimethyl ammonium chloride until about 15 years ago was the only molecule that was a fabric softener. They've since found a way to replace this group with something cheaper that's also a tallow type group, but it's cheaper. But until even today, about 40–50% of fabric softener is this molecule. Now, how does a fabric softener work? Well, this group is 16 or 18 carbons, and it's very long carbon chain. We've only been saying 10 and under, but this is much longer. When we get into fats and oils, I'll teach you more about this. Well, the positive charge here on the quaternary ammonium salt helps attract the quaternary ammonium salt to your clothing, like your shirts or blouses or whatever you're softening. And because that long R group feels very slick or smooth, that's how you make your cloth fabrics of your whatever you're washing and using a fabric softener with feel nice and soft. Ooh, that's nice and soft. Now, I've worked in this industry for many, many years, and I have a number of patents. So let me share some things with you. First of all, putting the dryer sheet to use the fabric softener in your dryer works a lot better than putting the liquid in your washing machine. You get more fabric softener on your clothing. Now, have you ever had older towels that, how come it doesn't absorb water as much? Well, I'll teach you about cotton, but towels have hydroxyl groups that can hydrogen bond to water. Now, if over time you have enough quaternary ammonium salt on your clothing or your towels really, that blocks it from doing that. And you know how you get your towels back to how when they were almost brand new and really absorb water real good, got you dry real quick? You wash it once or twice and don't use a fabric softener. And that pulls off the fabric softener, the quaternary ammonium salt. Now, why use a quaternary ammonium salt to begin with? Because when they came out in the 50s, early 60s, with the laundry detergents we now use, and I'll teach you about it, they're called LAS, linear alkyl sulfonates. They stripped all the fat and other things, chemicals off your clothing that you were washing that made them feel soft. And a quaternary ammonium salts, fabric softeners, are just putting it back on there. Now, do I have time? I do. Having worked in this field, I worked for a company, back then it was called Ccleaner. It's since been sold and spun off as its own company called Nurion. And Axo and another company made all the fabric softener, ditallow dimethyl ammonium chloride in the world. and I worked for it. My job was in charge of all research in the United States for quaternary ammonium salts and other amines for Chemie. And so I worked heavily with Procter and Gamble and also Lever Brothers, which you know as Unilever, maybe you don't know, Unilever. And P&G, Procter and Gamble, was Downy fabric softener. And Unilever, Lever Brothers, was Snuggle. Now, it turns out, because I got known by those companies, because I worked heavily with them when they had problems, Unilever made me an offer, and I'll talk about it later. I think I might have mentioned it, to work for one of their divisions that I couldn't refuse. They doubled my salary. Yeah, doubled it. Goodbye, Axel. But anyways, when I worked for Unilever, and it wasn't in quaternary ammonium salts, bad Dr. White, I said I wouldn't use slang, but a precursor, fat, carboxylic acid. As being a senior manager, I'd go to England, where Unilever is headquartered, and they'd have sometimes these get-together, research and development get-togethers. Do you know chemists know how, organic chemists know how to party hard, especially on corporate money? But anyways, and one time I'd gone over there. It was when I'd just been hired, or second time I was over there. And we were in this nice pub outside of Manchester. I forgot, I think we were in Littleborough. But anyways, that's in England. And we're partying hard. And someone who came up to me and we were talking, said, there's the research director. Go over and ask him about the Snuggle Bear. I said, why should I do that? Because you'll hear a good story. And so I went over there. What do I got to lose? They could fire me. They won't for that, but I've been fired in my life and you survive. So I went over there and introduced myself, and he had already heard about me because I'd already made some waves, solved some big problems for the company. And I said, someone was telling me you have a great story about the Snuggle Bear. I said, yeah, I do. I said, could you tell me? He said, sure. When they came out with this, or about to come out with a new, actually the dryer sheet, and also their fabric softener, Unilever was looking for some sort of logo or mascot to use for that new product line. Well, anyways, as the story goes, Unilever people in marketing sales decided, let's have a competition. And we'll pay someone a nice amount of money if we pick their design. Well, that got everybody fired up and putting in designs. You should use this, this, and this. Because I forgot it was either 10 or 25,000, a nice amount of money. I don't know what that is in English pounds, but it was still a lot of money. So one day, the story I was told, which other people told me it was true, that this research director, I can't remember his name, I can picture his face, but not his name, said, I was about to go to work and I was kissing my 4-year-old son goodbye. He's holding his teddy bear. And this was sort of a beat up old teddy bear that he loved. All of a sudden I said, can I borrow that? He said, no. And it took me a couple of days to convince him I'd give it right back. I took it and said, this is your new logo. And he did bring it back, so his son was happy with them. And that's how they found their logo, this little teddy bear on Snuggle. Now, hold on a second, because I forgot to get something. I'll be right back. It's show and tell in a minute. Normally, if we were face to face, I would have a small sample, but we're not. So it's time for Dr. White's show and tell. By the way, when I was in 6th, 7th, and 8th grade, we had show and tell, the teachers were scared what I'd bring in, only because I'd bring in something scientific or talk about something scientific. They had no idea what I was talking about. I did, they didn't. But anyways, mouthwash. Now, this is the Walmart equivalent of Scope. See the green color. Now, remember the first day I'd say you learn a lot about me? Well, unfortunately, due to heredity, I inherited dental problems. They're not dental. Well, anyways, it runs in our family. My mother's sister. Oh, all right. But anyways, one of the problems I had was with gums. If I went like this, I'd be in pain. So I went to this. I had a great dentist, unfortunately passed away a long time ago. He said, all right, you need a good mouthwash that he wrote a prescription for. And it was a small, like 20-ounce bottle or something like that. It was lasted a month, and it was like about $65, $70. It was expensive, and your insurance didn't pay for that. Well, it helped my gums. It was the stuff also you had to watch out for. It turned your teeth brown, light brown, so you had to brush them real hard every time you use this stuff. Anyways, he had to retire, and I was in between dentists. All of a sudden, I ran out, and my gums were hurting me. If I went like this, ouch. So I said, wait a second, you're an organic chemist. So I looked at the bottle, and I said, it's got an antimicrobial compound. So I figured, all right, let's go to a big box store. I went to Walmart. I usually go there about 4 times a year. I try and stay out of it. I don't need to go in there. I'll spend too much money. Do the same thing at Costco. But anyways, so I saw there were 2 types of mouthwashes. One used a phenolic compound, benzene ring with a hydroxyl group with an R group on it that has antimicrobial compounds. And that's the Listerine and Listerine type. So I bought a bottle. Guess what? It did zippo, nothing, zero. My gums still hurt. So I went back to Walmart and looked at the label. And what you don't know, and I'm going to teach you now, is quaternary ammonium salts. Like I said, they're fabric softeners, but another important type of use for certain types of quaternary ammonium salts are their antimicrobial and also antiviral. And if you look at the label here, it says right here, which you probably can't read, cetylpyridinium chloride. Now, that's another way of doing common names, and that's a quaternary ammonium salt. And I'll show you the structure in a second. So I bought a bottle, stethoscope, the Walmart, their brand, their own stuff is quite good quality. I've learned over the years. So it's like half the price. So I bought this and started using it. All of a sudden, no gum problems. And having known quaternary ammonium salts, guess what? I use that knowledge too, and it's a lot cheaper than what I was paying for. That's not what I want. Now, the one that keeps my gums nice and healthy now I'll teach later on. This is called a heterocycle compound. And this nitrogen has 4 different groups. Now, the double bond counts as 2 groups, and this is a quaternary ammonium salt. Now, interesting enough, when you have this type of quaternary ammonium salt, there's other types. this, or R or C8 or C10, didecyl ammonium chloride or dioctyl ammonium chloride, a dimethyl dioctyl ammonium chloride. This is really great antimicrobial, antiviral compound. In fact, they've been using this for a while in hospital surgery rooms. And if you follow in the pandemic, which I do, it's found along with other quaternary ammonium salts to kill COVID-19. Now, you can't take it in your body, just like you can't take bleach will kill COVID-19. But one of the things I started doing whenever I came back from going outside, even with a mask, I'd always rinse my mouth with this, because that's also been proven to have some efficacy on COVID-19. So quaternary ammonium salts are amazing compounds. Now, I invented some, and one of them is antimicrobial, used in surgery, cleaning operating rooms. And they also found it was good for killing bacteria in hot tubs, and it's been used for that too. Everything you want to know about quaternary ammonium salts, and we're afraid to ask. Now, do I have time? Oh, yes, I have one more time. Now, one of the hardest things in chemistry or anywhere to quantify is odor, what you smell. And it's a very important aspect of many products. Now, I've been working at Axo, and one of our biggest customers, period, dollar-wise, of all of Axo, when I was there, was Procter & Gamble, Downey. And one day I get a call in my office from the VP of Marketing and Sales telling me we got a problem. I said, what's wrong? It's with Procter & Gamble, P&G. What do you mean? Said, well, they decided to do a new formulation of Downey with a slightly different perfume, and our quaternary ammonium salt. They had a trade name, Arquad HT, Arquad HT, DM2T. No, I'm sorry, I got it. 2HT75. I hadn't thought about that name in eons. Makes the new product smell bad. What? We've been shipping that to them for eons. Well, that's what they say. So I started setting up, trying things to see if could we smell a difference. And we got a sample of our competitor's product. There's ways chemical companies can do that. And I couldn't smell a difference. We had panels set up. I set up throughout the whole research building, even outside of my research group, because it was that important. A research director got that set up in our building. There are 150 people there. And I was getting a call from the president of Axo in the United States when I got in my office in the morning, right before lunch and right before I got home. Did you solve it? Which was not fun calls to get. After a couple of weeks, I realized I'm spinning my wheels. So I called up the VP of Marketing and Sales and say, I've got to go to Procter & Gamble and find out what are they talking about? Because I have no idea. If I don't know what the problem really is, I can't solve it. Well, it turned out that wasn't that easy. Finally, I got a call back from a senior vice president of Procter & Gamble. Said, all right, we're going to set up a meeting and you're going to meet with one of our senior perfumer who's in charge of household products, including Downey. And let me tell you some ground rules. One, at that time I smoked, thank God I gave it up. You can't smoke for 24 hours before you come meet this guy. Okay. Two, you better be really nice to him, because if you get him upset, we will cancel our contracts with their company. Wow. We're talking about $75 billion a year in profits. That's a heck of a lot of money, excuse language. And just be real nice. I'm going to be there. And I said, can I bring our product manager? Okay. Now, over that time, I'd been working with a senior research manager at Procter & Gamble. And I said, could Joe at your company? No. We keep this senior perfumer but he should be there. And finally, I convinced him to be there. He had never been allowed to meet this guy. So we had a meeting. It was interesting. There were about 7 people or 8 people around the table, and essentially just between me and him. The others were just there to watch or listen and make sure I didn't mess up and be mean to this person. And he was a great guy. I don't remember his name. And he was one of the 5 perfumers in all of Procter and Gamble that made sure what it smelled like today, a product, what it smelled like yesterday, will smell like today, and it'll smell the same thing tomorrow. Because if you buy something you've been buying for years, smells different, there must be something wrong with it. I want my money back. And to this day, your nose, they haven't found anything analytical, electronic that works as good as your nose. So I went and we had the meeting. The first thing I asked him was, I was told our quaternary ammonium salt makes your new products stink. He said, no, that's not right. I said, well, tell me what's right. He said, the intensity of the perfume using your product is a little less than your competitors. Oh, really? Yep, that's the big problem. And once I knew what the problem was, I knew how to address it and go after it. It took me about 2 weeks working with other chemists in our research field to solve it. I do remember one thing this guy said, you know something? Yesterday I smelled something so strong it blew out my nose for the whole day. I should have gone home. Nobody laughed. And I was very polite, and I got a call back later on from the senior vice president thanking me. And then my colleague over there, he called me and thanked me, said, I never was allowed to meet this guy. These 5 perfumers were so powerful, important to Procter and Gamble. They kept them totally sheltered from even people in P&G. And that's my odor story. And I stopped getting those calls from the president in the United States. Oh no, it's time for a break. Let's take a 5-minute break, come back at 1:56, and I'll see you in 5 minutes. Let's get back to work. All right, everybody back? I hope so. All right, we're talking about amines and quaternary ammonium salts. I gave you a nice background. Those stories, I won't tell you the one about when I did some consulting in Guadalajara. That's real wild. Ooh, Guadalajara, what a wild city. Anyways, switches off. When we talk about amines have the smaller ones, very strong ammonia odor. And because they can hydrogen bond, the larger ones, after about C5, C7, 7 or 8 carbons for sure, and longer, there's liquids or solids at room temperature due to hydrogen bonding. Switches off on this slide. Now, how do you make amines? This is a busy slide, and I'm going to go through each one of these steps one by one, how you make primary amines, secondary amines, and tertiary amines. And I'll do and let's take a look at the first one. And by the way, I don't know what this is from my drawing software, so I can't change it. That 3 should be subscript. And let me go to my whiteboard and let's talk about synthesis of a primary amine. And here you take an alkyl halide plus ammonia, and you need base. I'll teach you later on why you need that base, but now you need base. Now for this, X is, as you know, chlorine, bromine, or iodine. Now, this is called nucleophilic attack. Nucleo, positive, file loving. And instead of saying bonding, organic chemists are violent, we say attack. Actually, if you look in the literature, people use that terminology. And the non-bonding pair of electrons are always looking for anything positive. And a carbon with a halogen, this is slightly positive, this is negative, because there's a difference in electronegativities. And what happens is this attacks that, kicks out that, plus loses a hydrogen. You get HX, which is an acid, which is neutralized by the base, and you make a primary amine. Now, remember, nitrogen in amines has 3 bonds to it, not like carbon. Nitrogen in amines has 3 bonds to it, and notice 2 hydrogens, 1 R group. Now, the carbon with the halogen is the carbon this nitrogen is bonded to. The carbon with the halogen is the carbon this nitrogen is bonded to. Now, there are many bases you could use. In industry, we usually use sodium carbonate. But anyways, I'm just going to put the word base. So if we look at this reaction, the question is, what's the organic product or product for the following? If I look at that, what's different? What's not a carbon or hydrogen atom? Ooh, a halogen on a carbon. This is an alkyl halide. That's ammonia. I'm reacting with base, and you get a primary amine. Primary meaning one R group on nitrogen. So what's my R group? Well, I'll rewrite it because you know you don't break carbon-carbon single bonds. Which carbon has the halogen? Is this carbon? And now I'll have my NH2. And you made isopropylamine. Again, look for what's different. Alkyl halide, ammonia, the carbon with the halogen is the carbon that the NH2 group, in this case, will be bonded to, the nitrogen will be bonded to. Everybody read cursive and see that base. Give me a thumbs up if you can read the base with cursive. Or if you don't want to give me a thumbs up, send me an email if you can't read cursive. Now, from my head, but nobody's complaining. All right, your turn. Draw this, give the product or draw the product for the following reaction. 3 points each. Thank you, Megan. Thank you, Joe. All right, I think everybody's done. Let's take a look at this. Now, if I look right here, what's different? What's not carbon? What's not hydrogen? Ooh, iodine on a carbon. That's an alkyl halide. Remember, X can be chlorine, bromine, or iodine. Ooh, ammonia. That's sure different. Base. And what do you get? A primary amine. And what's my R group? This right here. Notice the carbon with the halogens, that carbon. Since I don't break carbon-carbon single bonds, you don't. I have my 4 carbons. Which carbon has the halogen? This one will have NH2. Remember, there's 3, yes, it means 3 bonds to nitrogen. And I know there's 4 bonds to carbon. The NH2 group counts as a group. So this carbon has 2, 4 minus 2 is that. And that's how you do it. Oh, let's do another one. These are fun. On test number 3, like test number 2, I'll have about 4 synthesis problems. And the question would be, what would you react with ammonia to make that product? This is the fun part of organic chemistry, synthesis. How do you make things? And that was part of my job at Axel, was to come up with new products and figure out how to make them. Now, the one thing you don't have to worry about was part of that new product, how to make them, was they had to be in a certain price range. which made life quite interesting. Doesn't it feel good? It doesn't hurt to do organic chemistry. Thank you. I see Megan and Joe are done. If we're in a classroom, I'd be looking around and I could tell when everybody's done. They give me that look like, get to work. All right, I think everybody's done. So let's take a look at how do you do this? Well, you look at the product. What's different? What's not carbon? What's not hydrogen? Ooh, a nitrogen with 2 hydrogens on that carbon. This is a primary amine. I'll never ask on a test what's a primary, secondary, tertiary amine, but I'll use that terminology. And what do we react with ammonia? An alkyl halide, where X can be chlorine, bromine, or iodine. Now, if you notice here, I didn't put the inorganic stuff, which would have told you what we started with, X. Therefore, you could pick any one of those would be correct. So what's my R group? 4 carbons. The carbon with the nitrogen in R is the carbon with the halogen Rx. And therefore, we have 4 carbons. We didn't add any carbons. So I better start with 4 carbons. Which carbon has the amine or amino group? The end one. Therefore, this one will be the halogen. I'm going to pick bromine. I could have easily put chlorine or iodine here too. There's 4 bonds to carbon. And that's how you do that. And that's how you make a primary amine. Now let's go back to my too busy, overcrowded slide. Once you have a primary amine, what can you do with it? React it with the same or different alkyl halide. That's what this is called, alkyl, R group halide for halogen, with base. And now we make a secondary amine. So a primary amine plus the alkyl halide. Remember, I don't have it on the slide here, bad Dr. White. X can be chlorine, bromine, or iodine. In base, you make a secondary amine. And the only reason I use R prime is because it can be the same or different than the R group on nitrogen that's there already. It doesn't matter which side you put the R groups. Now remember, amines have 3 bonds to it. I have 2 already, so I need another hydrogen or a hydrogen. And let's take a look at this. Now the question would be, what are the products, organic products or products for the following 3 points each? And look at the first compound, what's different, what's not carbon, what's not hydrogen, a nitrogen. So this is a nitrogen with 1 R group. R group is methyl. two hydrogens. That's a primary amine. The second compound, carbon, halogen, that's an alkyl halide. And we're reacting with base, and we get, and it doesn't matter which side you put the hydrogens, the R groups, there are many different ways I could write that. You get a secondary amine. And here, the carbon in R prime with the halogen is the carbon in R prime that the nitrogen will be bonded to. Again, the carbon in R prime with the halogen will be the carbon R prime is bonded to the nitrogen. So here we have R. Here we have R prime. Notice the N carbon has the halogen. My methyl group will still be on the nitrogen. I now have 3 carbons to the end and propyl. And there are 3 bonds to nitrogen, so it's got a hydrogen. And that's how you would do it. And the question would be, what is the organic product or products for a following reaction? Thank you, Calvin. Thank you, Joe. If you're done early, please be patient. I want to give everybody time to finish. Thank you, Emily. Oh, not Emily. Looked at the wrong place. Bad dog. I gotta get new glasses. Thank you, Megan. Sorry. And let's get going. What's different here? Ooh, nitrogen on a carbon. That's a primary amine. Ooh, carbon. Ooh, a halogen on a carbon. Then carbons here and hydrogen. That's an alkyl halide. And remember, X can be chlorine, bromine, or iodine. And in the presence of base, you will get a secondary amine. So if we look at here, here's my R group. Ooh, this is a big one. That's R prime. Notice this carbon has the halogen. The carbon with the halogen is the carbon bond to the nitrogen. And therefore, I know I don't break carbon-carbon single bonds. And also, because I'm an organic chemist, I know I'll draw the first group 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5 carbons. That's good. This carbon had the halogen, will now be bound to my nitrogen. And then my R group methyl will still be there. And it will have one bond, one more bond, because there's 3 bonds to nitrogen. And I do that with the hydrogen. And now I know there are 4 bonds to carbon, so I can put in my hydrogen. Now, you could have drawn it where this 5-carbon chain was on this side, or the switch with the hydrogen, nitrogen. All you're doing is rotating things around. Now, one of the things I haven't gotten into, we'll get into in carbohydrates, molecules like you and me aren't just glued to a piece of paper. We rotate. And now we're getting to products where you'll see, oh, you drew it this way. How come is mine wrong? No. I'll give you an example. Here's my right hand. If I said, close your eyes, I went like this, I said, oh, look, something different. You said, nah, you just rotated your hand. Or if I said, here's my right hand, close your eyes, and I went like this, oh, look, something different. No, you just rotated 90 degrees. And molecules like my hand or this pen rotate all around. So there are different ways of writing them. All right, let's have some fun with a synthesis problem. What 2 things would you react together in the presence of base to make that molecule? Have fun. Which this is the fun part. Anybody keeping track how many times I said fun this semester? I think I should go for the Guinness Book of World Record. While you're doing that, I'm going to get a new bottle of water because I'm just about out. I'll be right back in about 1 minute. Time me. Anybody time me? If you're done, give me a thumbs up. And thank you, Megan. Thank you, Calvin. Thank you, Joe. And let's take a look at this. And Emily, if you can't do a thumbs up, I understand. All right, if we look at this, what's different? Ooh, nitrogen. It's got carbons here, and 1 hydrogen. And what is this? A secondary amine. And what 2 things do you react with base to make a secondary amine? A primary amine plus an alkyl halide, where X can be chlorine, bromine, or iodine. And if I look at this, I say, all right, I'm going to make this my R group and this my R prime. If I do that, my R group is this. Remember, there are 3 bonds to nitrogen. And here my R prime is this, pick a halogen. Oh, I haven't used bromine, but you could have put chlorine or iodine there, and that's what you have. But wait, there's another way I could have done it. I could have said the methyl group is R prime and the ethyl group is R. In that case, that would be my primary amine, and my R prime now would be, I could have used iodine or chlorine there. Which one of these is correct? For my class, either one. In reality, one's cheaper than the other, and I would think this would be a little less expensive. Not that much, but that's because I know cost accounting, which even in graduate school, they don't teach cost accounting. I had to learn that on my own once I got into chemical industry. I think I mentioned one of the greatest regrets I had from my undergrad and grad school time was I didn't take a good course in basic business accounting. So being a PhD chemist or PhD, once I got in industry and found out I needed to learn that, I asked my accountant at the time, what's a good 101 accounting book? And he gave me one of his and I read it and learned accounting. Anyways, that's how you make secondary amines. Now, if we go back to the slide, oh no. There we go. We know, now, hold on. Let me try one thing first. Let's see. Oh, let me show you something. If you don't know about Ccleaner, which is free, don't buy their Primo Pro stuff. This is just a great way of cleaning out a lot of unused files. Since I got Firefox running, I skipped it. If it wasn't running, I would have done this. And this gets you out of a lot of problems sometimes you have when you get certain types of not spyware or ransomware, but certain files that want to take over your computer. You run this, it knocks them out. When you get something from the internet, opening a website. But anyways, let's see if this did it. I think it did. I think I had too many files open. All right, let's take a look at this. And the last thing I'd like to talk about with the right color pen. Nope, it didn't. All right, sorry about that delay. All right, let me think what I really need to do, which I've been holding off on because it's going to cost money, is get more memory for this machine. I got 18 meg. I should bring it up to 32. Anyways, let's look at the last on this. You take a secondary amine and react it with an alkyl halide. Remember, X can be chlorine, bromine, or iodine. You get a tertiary amine. And that's what you get. So let's have fun with this. And it doesn't matter which side you put the R prime, and R double prime, and you make a tertiary amine. So if we look at this, let's have some fun. Remember, the carbon, in this case, R double prime with the halogen, will be the carbon the nitrogen is bonded to, R double prime. This means double prime in the tertiary amine. But in this case, we don't have to worry. And if we look, and the question would be, what's the organic product or product for the following? I'm going to take a drink of water because I'm writing more on the board or whiteboard, so I'll give you time to copy it down. And tonight at midnight, I'll be giving speed structure drawing lessons. No, I won't. All right, let's take a look at this. What's different? What's not carbon or hydrogen? Oh, nitrogen. It's got an R group here and a different R group, alkyl group there, and a hydrogen. This is a secondary amine. Oh, carbon, oh, halogen, that's an alkyl halide. And remember, X can be chlorine, bromine, or iodine. And here, what's our R group? Oh, first of all, let me finish this. And you make a tertiary amine. Tertiary means 3 R groups, secondary 2, primary 1 on the nitrogen. And notice in the tertiary means there are no hydrogens. Why? Because in amines, there's 3 bonds to nitrogen. So I'll call this R, you call it R prime, doesn't matter which you call here, R double prime, R triple, I'm over priming. R single prime and R double prime. Now, therefore, I'm going to have my nitrogen, R, R prime, and I could have put the methyl group on that side too. There's free rotation around the carbon nitrogen single bond. And my last R double prime is here. Now notice that's dimethyl ethylamine. I could have also written it, which I might on a test, And these two compounds are the same. It's just different ways of drawing it. This tells me inside the bracket, whatever is there are two of them on that nitrogen, in this case, methyl groups. So you made dimethyl ethylamine, and that's how you do it. Let's have some real fun. This is a cyclohexane ring. And the question would be, give the product or products for the following reaction. 3 points each. Oh, by the way, keep that secret of mine about my mouthwash that I used to yourself. Not, I'm not going to cut it out of the video. That's better. The cyclohexane ring I had before, I didn't like the way it looked. And a whiteboard and or face-to-face, that happens too. And when you're done, give me a thumbs up. Thank you, Megan. Thank you, Joe. All right, thank you, Calvin. Let's get going. Now, if we look at this first compound, what's different? What's not carbon? What's not hydrogen? Ooh, nitrogen. It's got a methyl group and a cyclohexane ring, and those are R groups. R groups is something that has carbon, hydrogen in it. So this is a secondary amine. And ooh, carbon with a halogen. An alkyl halide, where X can be chlorine, bromine, or iodine. In the presence of base, you make a tertiary amine. And it doesn't matter which side you have R prime, and R double prime. All this tells me is you could have two that are, all three are different R groups, or they could be a combination. And if we look here, what's R? I call that R prime, call that R double prime. And therefore, I have my methyl on nitrogen, my cyclohexane, and the other methyl group. Now, you could have also written it this way. And that's, I'm having a terrible now I have bad hair days. Well, I'm having a bad ring drawing day. That's better. And either one would be correct. Now, one of the questions I've been asking you to ask is, why am I learning this stuff? And the obvious answer for you is what you've heard me say before. You want a good grade so you can get into a program or a school that has a program you want to go to, like nursing school or others, dietitians or pharmacists, physicians, assistant or doctor's assistant, all those. But why learn this stuff? Let's look at that molecule you just made. Now, this molecule, which is dimethyl cyclohexylamine, has a trade name. And it's called polycat 8. And it's been made, let's see, when did I first learn about it? About 1984. So it's been around for a long time. It was around before that. And it got the name polycat 8 because it has 8 carbons. 2 plus 6 is 8. Poly for polyurethane, cat for catalyst. Now, there's a special type of polymer, and later in the semester, I'll talk more about it. I think I talked about polyurethane already in polymers. And this tertiary amine is one of the best catalysts for making urethane foam. And it's called polycat 8 for polyurethane catalyst, 8 carbons. Now, how do you make it? Well, you just learned how to make it. And this compound is useful for making urethane foam insulation, like that goes into insulating your refrigerator and your home. And it can also be used to make another type of urethane, polyurethane. It's called flexible polyurethane. And that goes for things like your pillows, your car seats, your furniture. I don't know about you, but I don't want furniture that feels like you're sitting on a piece of wood. I like it nice and soft and cushy. And that's how you do it. Oh, let's have fun with this reaction again. And the question would be, what would you start with those 2 compounds to make that new molecule? And don't forget, there's only 6 more shopping days till Halloween. I think I'm going to put up my sign again, no trick-or-treaters. Not that I want to, but with the Delta virus still going and kids not vaccinated, I think that's safe for Dr. White. And that, I'm very selfish. I want to stay healthy and alive. 2 things very high on my list of things I want to continue doing. Thank you, Joe. Thank you, Calvin. And if you're not done yet, take your time. Thank you, Megan. I think we're done. And if we look at what are we trying to make, what's different? Ooh, a nitrogen. Yeah, that's an N with 3 alkyl groups. In this case, they're all methyl. But this is a tertiary amine. Our prime and our double prime can be the same, like in our example, or they could be different. And what do you react with base to make a tertiary amine? A secondary amine plus an alkyl halide, where X is chlorine, bromine, or iodine. And if I say the 3 methyl groups are R prime, and our double prime. So what does that mean? The first, my secondary amine, would have 2 methyl groups, which I can write like this, or you can write like this. which on a test I more likely would do. And my third, our double prime, is a methyl group. And you could pick any one of these. I haven't done chlorine in a while. Could have put bromine or iodide. Those all would be correct. And that's how you make tertiary amines. That's not what I wanted. Now, if you notice, this nitrogen on tertiary amines still has, you don't normally draw that, the non-bonding electrons. And nitrogen has that. Well, it turns out you can react those non-bonding electrons. And now we're going to do a very important reaction because it's near and dear to my heart, because it helped pay my mortgage off, a couple new cars, got me around the world. That's how do you make a quaternary ammonium salt. And you take a tertiary amine and react it with an alkyl halide, where X can be chlorine, bromine, or iodine, in the presence of the base, and you make a quaternary ammonium salt. And quaternary ammonium salts are used for many things. So let me rewrite this. And that story I told you about the odor, my knowledge of this reaction, I was able to, with the help of Dr. Chunan Wang, who ran our analytical group, what a great chemist. I haven't talked to him in decades, but I hope he's still alive. I told him what I was looking for, and he was able to pinpoint what I thought by gas chromatography. We solved it, and I manipulated this reaction to get rid of that odor, or that problem wasn't really. Again, this is called a quaternary ammonium salt. And if I look at the clock, and let's take a look break right now. I'll give you an extra 35 seconds over our 5. Don't tell the dean I'm letting you spend all that free time, and come back. Oh, it is. I'm not giving you any free time. Come back at 2:50, and I'll continue with quaternary ammonium salts. Dr. White has a big smile on his face now. Not because of the break, because of quaternary ammonium salts. Come back in 5. Time to get going. Come on, wherever you are. Everybody back? All right. Quick public service announcement from your host, me, Dr. White. Don't forget, there's a lab due this Wednesday. Keep on handing in your labs. I appreciate it. Also, it's good for your grade because labs are, how should I say this, easy points. Not that easy, but they're not that hard either. But you got to hand in the lab. And don't forget, tonight from 5 to 6:15, I will be having on Zoom my office hour, actually office hour in 15 minutes. And if you have any questions, please stop by. All right, we're talking about quaternary ammonium salts. And you take a tertiary amine, react with an alkyl halide in the presence of base, and you get a quaternary ammonium salt. And don't forget, you always have to have an anion because all molecules have a net zero charge. But when you write it, you don't have to put the charges in. I always do. Good habits I won't change. All right, let's do a very special reaction to me. And I'll do this one. And this is very special to me because it helped pay my mortgage and a whole lot of other good things and got me around the world. All right, let's look at this. What's the product or products, organic product or products for a following reaction? So we look here and say, what's different? Oh, nitrogen. And this is a tertiary amine. Remember, this means there are two R sub T tallow groups on that nitrogen. So I can call this R and R prime, and I'll call that R double prime. And then I come over here and say, ooh, methyl group with a chlorine, alkyl halide. In the presence of base, I'll make a quaternary ammonium salt. Remember, X can be chlorine, bromine, or iodine. And this is my R triple prime. So I have my nitrogen. Now there are two ways I could draw it, actually more than two ways, but the two main ways most students would draw it this way. You don't have to put the charges down. What's my halogen? Chlorine. Now this can go anywhere. Remember, this chlorine is bonded to the nitrogen, not this carbon, but it's convention, you put it to the right of the cation. By the way, this is a cation, which I'll never ask on a test. And this is the anion. If I could spell it. And the other way I could have drawn it, which I would normally do, so I'm a lazy organic chemist, would be that way. And you made ditallow dimethyl ammonium chloride. Like I said, for many years, this was the only molecule used as a fabric softener. And when I was at AXO, we used to make quaternary ammonium salts using this one reaction and this one a lot, to the tune of about 2 to 3 million pounds a week. Whoa, yeah, 1,000,000 pounds a week. Oh, time to teach you something. How many of you have ever seen those trucks that deliver gasoline to a gas station? Give me a thumbs up if you've seen that. They're long trucks. All right, I think most of you have. And those are called tank wagons, because in the old days, I actually saw one in Germany at a celebration at a company I worked for. That's when I was part of Unilever. An old wagon with a big tank on the back being pulled by horses. And those are called tank wagons. They're standardized, the ones you see in a gas station, or if you see on the road carrying chemicals or milk, which is really a chemical if you think about it. I'll teach you more about milk later in the semester. But anyways, those are standardized, 40,000 pounds, 5,000 gallons. And railroad cars come in, tank cars come in different sizes too. But anyways, think about 2 to 3 million. How many of those a week was shipped at this one plant, really in Morris, Illinois, that I used to go to? But anyways, so that gives you an idea of the scale of industrial chemistry. I've got a surprise later in the semester, but I can't tell you about it, or it wouldn't be a surprise. And what would be the product or products for the following reaction? 3 points each. And if you haven't looked out your window lately, it's really windy out there. If I took a break, I looked out, I can see behind somebody's window, behind themselves, the trees and the shadows. But anyways, when I looked out my weather window, my front window, I could see the 2 trees in front of my house, my neighbor's trees. It's one of the reasons I like where I live, because we still have a lot of trees, lots of trees around. They were really moving. All right, speaking about moving, give me a thumbs up when you're done. All right, everybody's done. Let's take a look at this. What's different about the first chemical or reactant? That's a nitrogen. Remember, look for what's not carbon, hydrogen, or carbon-carbon single bond. And notice I have not 1, 2, but 3 groups on that nitrogen. Remember, nitrogen has 3 bonds to it for amines, but quaternary ammonium salts have 4 covalent bonds. And what do I have here? Carbon, a halogen on a carbon alkyl halide. And X can be chlorine, or in this case, it is bromine, or iodine. And in the presence of base, you make a quaternary ammonium salt. And if I look here, I can say, and there are many ways you can parse this. That's R and R prime, that's R double prime, and that's R triple prime. So I'm going to take my nitrogen and my 2 R prime and R double prime, I can write like this. And then I can put on any one of these three sides our double prime. I'll put it here. Then the carbon with the halogen is the carbon, three carbons, because we don't break carbon, single bonds. Now, there are other ways I could have drawn this. I have two methyl groups on the nitrogen, isopropyl and N-propyl. And then, don't forget, I almost did, don't forget the anion or I'll take off points. In this case, it's bromine. And that's a quaternary ammonium salt. And let's have fun with synthesis, because that's the fun part of organic chemistry, but I'm biased because I'm a synthetic organic chemist. And the question would be, what two things would you react in the presence of base to make this molecule? Thank you, Joe. Thank you, Megan. Thank you, Calvin. Let's get going. All right, if we look at this product, what's different? Oh, it's a nitrogen and it has four R groups on it. It's a quaternary ammonium salt. And what do you react with base to make a quaternary ammonium salt? A tertiary amine and an alkyl halide. And remember, over here, X, and over here too, can be chlorine, bromine, or iodine. And in our case, it's an iodine. So what I can do is I can say, well, I'll call this R and R prime and R double prime. I'll call this R triple prime. Well, if that's the case, then my tertiary amine, which I can write this way, all three groups are R prime and R double prime are methyl. So I take trimethylamine, and my R triple prime is ethyl, and my halogen is iodine, and that would be the answer. But wait, what if I call this R, then I call these R prime, R double prime, and R triple prime? If that's the case, I have ethyl is my R group, and my R prime and my R double prime, one way of drawing it, is methyl, and my R triple prime is also methyl. My halogen still And which one is the correct one, A or B? And the answer is they both are, because you don't know cost accounting and I do. And if I were to have to do that, I would probably go with A because I know that's slightly cheaper. But for this one, they're pretty close. And that's how you make quaternary ammonium salts. Remember, they're used in fabric softeners, they're used antimicrobial, and they have other uses, which I won't get into in this course. Now, that's all using alkyl halides to make primary, secondary, tertiary amines and quaternary ammonium salts. Now, let's look at a really nice reaction. And I'll explain why I'm smiling for this one. This is called a nitrile. And a nitrile is a carbon-nitrogen triple bond. And just like a carbon-carbon triple bond, you have 2 pi bonds and 1 sigma bond. And you learn with carbon-carbon triple bonds, you add hydrogen, a catalyst, and I don't have it here, but it should be excess. You break the 2 pi bonds. I can write it this way. And you make a primary amine. And this is probably one of the best ways to make a primary amine by hydrogenation of nitriles. And I won't go through the chemistry, but you can make nitriles from carboxylic acids, which you can get real cheap. And AXO, we used to make nitriles and do this hydrogenation to the tune of about maybe 4 to 5 million pounds a week. Yep, that much a week. That's just the United States. I forgot what they did in Europe. They made a lot too. So let's take a look at this. Now, yes, there are IUPAC nomenclature rules for nitriles and common names, but I'm not going to go over that in this class. Whoa, that's strange. I don't know why it changed. I forgot to write in the other one page, so I'm going to go back and do it. Remember, the catalyst equals nickel, platinum, or palladium. So if we look at this reaction, the question is, what's different here? Ooh, nitrogen, triple bond to carbon, a nitrile. And we have hydrogen excess because we have 2 pi bonds that we want to break. And we have a catalyst. And remember, the catalyst can be nickel, platinum, or palladium. And when I break the 2 pi bonds, each atom of the triple bond gets 2 hydrogens, which I can write this way, or I can write this way. They're identical. Either way is acceptable on a test. Well, what's my R group? This. And do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, plus this carbon, 5. So I'm going to have 5 carbons. I'm still going to have my nitrogen. I break the pi bond, 2 of them, and each atom of the triple bond gets 2 hydrogens, and I know there's 4 bonds to carbon, so I can put in a rest. And you could have also written it this way. And remember, for primary all amines, there's 3 bonds to nitrogen, which is why it has 2 hydrogens. Now, say hello to a very old friend of mine. When I started in industry, after coming out of academics, getting my PhD, and then being a postdoctoral fellow for a year and a half, that's where you work for another chemistry professor at a different university. And you're pleasantly poor, and you do that until you find a full-time job. Well, when I got hired at AXO, they made longer chain amines starting at 10 up to 20. And they were looking at how can we make inexpensive short chain amines. And I was given the job because I joined a group that initially did this process development. How do you get things to work in a plant? This reaction. And I got it to work better than they had been, but I found a better new way, which I can't tell you is still a trade secret, how to make primary amines. And this was the actual reaction. Now, quick little story. Here I am, brand new. I had never really worked much in hydrogenations or amines, but I got hired. I had a really great boss, Dr. Bob McDaniel. When I started out, he taught me a lot, and so did Sid Shapiro. So I'm learning about this, and I said, Bob, I went to his office. I said, I think we can help this reaction out. Instead of using nickel like they use in the plant, we'll use platinum catalyst. He looked at me and started laughing and said, why don't you go look up the price of platinum and come back, catalyst, and come back and talk to me about that. And I came back and it was like, whoa. It was like, I don't know, 500 times per price per pound. And he explained to me, because I'd never really worked in a chemical plant, he knew that. He was being, how should I say, educational, taught me a lot. He said, in a chemical plant, you lose catalyst. You can't recycle it that easily. So if you lose nickel, which is cheap, nobody cares. If you lose 5% platinum and it's expensive, you're going to lose a lot of money. In industry, we never use platinum or palladium because it's expensive. Now, in research and academics, they can, and certain pharmaceuticals, because they charge a lot for pharmaceuticals, they can. But basic industry, no, you can't. So we're not in industry right now, so I will give the organic product or products for following reaction. Thank you, Joe. Thank you, Megan. And we'll let everybody finish. Oh, Calvin's finished too, so I can get to work. And if we look at this molecule, we're trying to react with hydrogen excess because we have not 1, but 2 pi bonds, and platinum is a catalyst. And you can have platinum, nickel, or palladium. What do we have that's different? Carbons. Ooh, carbon, nitrogen, triple bond. And we call this the nitrile, which I'll never ask you on a test, but at least you'll know about it. And you break the 2 pi bonds, not the sigma. And each atom of the triple bond gets 2 hydrogens, which you can write like this or like this. And what's my R group? This. So I'm going to draw that. You don't break carbon-carbon single bonds. I have this carbon here, which is bonded to nitrogen. You break 2 pi bonds. And that's one way of drawing it. Another way of drawing it, I'll go up here because I need the space. And these two are the same, just different ways of drawing it. And that's how you do it. Oh, let's have some real fun. What would you react with excess hydrogen and palladium to make that molecule? Thank you, Megan. Thank you, Calvin. Thank you, Joe. You guys are getting the hang of this. Doesn't that feel good? All right, let's take a look at this molecule. What's different? What's not a carbon-carbon single bond or carbon or hydrogen? Ooh, nitrogen. And what is this? It's a primary amine. But since I see this hydrogen in a catalyst, I can write it this way. Let's call that R prime. And or I could also write it this way. And what do I react with a catalyst and hydrogen excess? Remember, a catalyst can be palladium, which it is, platinum, which is not in this case, or nickel, which is what I use. What did I use? Harshaw's 5132P. That's a special type of sponge nickel catalyst for these types of hydrogenation. I still remember that. I should consult with that. And therefore, what's my R group? Notice the carbon bonded to nitrogen is the carbon in the nitrile. So to break carbon-carbon single bonds, or I'm not adding any either, so I have my R group. I have this carbon right here, bond to nitrogen, will now be this carbon triple bonded to the nitrogen and the nitrile. And that's how you do it. And like I said, it's a wonderful way of making primary amines. I know, I used it. Isn't it nice you have an instructor who's actually used this stuff in the real world? Don't answer that. Now, let's talk about amines and the basicity of amines. Now, little review from general chemistry. Amines are bases. And a base is something that accepts a proton, H+. And if you put ammonia and H3 in water, you get ammonium hydroxide. In real life, this is really an equilibrium, but I didn't show that. How many of you have ever bought ammonia from a supermarket? You know, it's in a gallon bottle. Or how many of you have ever smelled it? And it smells real strong. And well, you're smelling the ammonia because of the equilibrium, but most of it exists as NH4 plus OH minus. And that's because this is a standard base acid or acid base reaction. And ammonium hydroxide is a salt. So let's look at what about amines? Well, you can form an amine salt. Now I'm going to rewrite this equation. Don't write this down yet. And these are bases just like, and if with HCl, you'll form, this is called an amine salt. Don't write this down because I forgot to change this, bad Dr. White. All right, write this one down. Now, what I've written here is a way of designating either a primary, secondary, or tertiary amine. And this nitrogen has R prime, and R double prime. Now, it turns out for this reaction, R prime and R double prime, both or one or none can be hydrogen. So that takes care of a primary amine when both are hydrogen, a secondary amine when one is hydrogen, and a tertiary amine. And if you react it with a base, an acid, I'm sorry, and let's just, there are many acids, but let's stick to the halogen acids, hydrogen, chloride, bromide, or iodine. What happens is a proton transfers and you don't have to write charges, but I do. And this is called an amine salt. All right, let's take a look at some reactions of amine salts. And turns out this plays an important role in medicine, which I'll tell you in a little while. And here we have what's different, nitrogen. We have a primary amine, but since I have an acid, HX, I could have a primary, secondary, tertiary amine. And remember, R prime and R double prime, either one or both can be hydrogen. And when you react these two together, what's attached to nitrogen initially, R prime, R double prime, and are still there. This has a hydrogen, now have a plus charge, and you'll have an anion. And here, what's our methyl? What's our prime and our double prime? Hydrogen, which it can be. And therefore, I'm going to have my nitrogen. It's going to have a methyl group. my R prime is hydrogen, my R double prime is hydrogen, and it gets one more hydrogen, and my halogen is bromine. Remember, X can be chlorine, bromine, or iodine. You don't have to show charges, I do. Now you could write it this way, or if you notice on this nitrogen, there are 1, 2, 3 hydrogens. You could have also written it now. I'd like you to look at this amine salt. Like quaternary ammonium salts, amine salts have 4 groups to nitrogen. That's why I say for amines, 3 groups, for quaternary ammonium salts, and now amine salts, you can have 4 groups. Now they can be hydrogens or alkyl groups. On an amine salt, one of the groups on nitrogen has to be a hydrogen. Because if there were 4 alkyl groups on there, that wouldn't be amine salt, it would be a quaternary ammonium salt. So amine salts, one of the groups on nitrogen has to be hydrogen. And then it can have up to 2 more hydrogens, R prime and R double prime, because R prime and R double prime can be hydrogen. And your turn. Thank you, Joe and Calvin. Thank you, Megan. I better get to work. If we look here, what do we have? We have a secondary, well, nitrogen tells me I have an amine. And because I'm reacting with an acid, I'll write the amine this way. HX is my acid. X can be, in this case, it is chlorine, bromine, or iodine. And here, remember, R prime and R double prime can be hydrogen. In this case, this I'll call R, doesn't matter what you call R prime. And, ooh, R double prime is a hydrogen. And what do we get? We get a amine salt. And don't forget the anion there. So in this case, R double prime, or R prime, R double prime, and then I add 1 more hydrogen. And you don't have to show charges, I always will. What's the X? Chlorine minus. And this is bonded to the nitrogen, not to this carbon. Oh, that was fun. Let's try another one. what would I react with HI, hydrogen iodine, to make that molecule? Thank you, Joe. Thank you, Megan. And thank you, Calvin. All right, good say. Thanks to all of you. All right, let's look at this. What's different? Ooh, a nitrogen with a plus charge, 3 alkyl groups and a hydrogen, an anion. That's an amine salt. Number X can be chlorine, bromine, or iodine. And what do you react? Notice this is HX. What do you react with HX to make this amine salt? You react a tertiary or whatever amine, primary, secondary, tertiary. Remember, R prime and R double prime can be hydrogen. I definitely think it's time to change the tip on this. And if we look up here, I can say R double prime, and our triple prime are methyls, or double prime, R prime, our double prime, and my halogen is iodine. And we know that already. So we take trimethylamine, which I can draw that way, or on a test, you could also draw it this way. And that's how you do it. Now, let's go through the nomenclature of amine salts, which I don't believe I have a slide for because it's real easy. I don't. So through the miracle of my whiteboard here, let's talk about amine salt nomenclature. It's real hard, not. And how do you do that? It's the same as quaternary ammonium salts. You name each. And this is a comment, I'm not going to teach IUPAC. Nobody ever uses that except in patents and also certain legal documents. All right, so you name each alkyl group R group in the front and add at the end ammonium halide at the end. Now, one of the things I always get asked at this point is, well, how can you tell the difference between an amine salt and a quaternary ammonium salt? Well, for an amine salt, you never have 4 R groups, 3 or less. For a quaternary ammonium salt, you always need 4 R groups. So let's take a look. And the question is, what's the common name for the following molecule? Well, if we look at this, it's got this structure. Don't forget the cation, which I almost did. Bad, Dr. White. So how we name that? And since it's common name, doesn't matter which one we start first. And what's the halogen? Chloride. And that's how you do amine salts. So I'm going to give you one to try. And there you go. What would be the name, common name of that molecule? Remember, it's just like a quaternary ammonium salt. Name the alkyl groups, then ammonium halide. And when you're done, give me a thumbs up. Thank you, Megan. Thank you, Joe. And thank you, Calvin. So let's take a look at this. Ooh, a nitrogen with a charge on it. And there are 4 things bonded to it. And one of those 4 things is a hydrogen, actually more than one. And it's got a halogen anion. It could be other anions. Remember, for my class, X is chlorine, bromine, or iodine. And it's an amine salt. And what's our R group? Name each R group. There's only one. N-propyl, ammonium, and what's the halogen? Bromide. If I look at the clock, our time is almost up. So I better leave you with some important things. Don't forget, on Wednesday, I will go through the carboxylic acid ester problem set. Please do it before I do. So if you have any questions, you can ask. Did I say Monday? I meant Wednesday. On Wednesday, we'll do the next lab, which I'll post sometime tomorrow on D2L. And don't forget, after later on today from 5 to 6:15, I'll have my office hour, actually office hour in 15 minutes. And stop by if you have any questions, because there's no such thing as a dumb question. I'm there to help you. And with that, Oh, I timed it just right. It's time for me to say, Gang gesund, goodbye. I stole that from Granny of Beverly Hillbillies. I just did a generation gap thing on you. I used to watch that when I was in high school. Our whole family watched it. With that, I'll either see you later today or I'll see you Wednesday morning. Gang gesund. Goodbye.